Okay, 8.1 was estimating mu, or the population mean, when the standard deviation was known. Now we're going to talk about the population standard deviation being unknown. So in other words, like in most cases, researchers will have to estimate sigma, the population one, with the sample standard deviation, which makes sense because samples are a lot easier to create and grab. The sampling distribution for X bar will follow a new distribution called the student's T distribution. Now, the z-scores are in the back binding of your book. The t-scores will be in the front binding of the book. Usually mu and your sigma are unknown. We may not always be able to have a large sample. We will assume that the x distribution is normal, so we'll use your x bar as your sample mean, s as your sample standard deviation, n as your sample size. But now instead of a z-score, we'll find a t-score. Looks a lot like the z-score 1, except for instead of sigma, we're using s for your standard deviation. Properties of the t distribution. It's symmetric and centered around the 0, just like the normal one was. Now it's characterized by degrees of freedom, or D dot F. That's your sample size n, subtract 1, for mu confidence intervals. It's bell-shaped, but have wider, fatter tails than standard normal curve. A number of degrees of freedom increases, the tails get narrower, and the t distribution gets closer and closer to the normal distribution. So big really isn't defined like it is in standard normal distribution. Like it's not bigger than 30 is regarded as large. But here we go. Critical values, again, we'll have to know some sort of critical value for TC. C is the area underneath the curve that we want to be confident. So if we want to be 95% confident, it lies between these two t-scores, both negative and positive. But here's how you are going to use your table. There is a C/DF. It might be written a little bit differently in the book. I think it's like this. That you're going to look across and you're going to find 0.95. That means you want to be 95% confident. DF is 7, so that means that your sample space must have been 8. So 8 minus 1 gives you that 7. You cross-reference that, and there is a critical score that goes along with you. On the back of the book, or the bottom of that book too, it says that if the DF, the degrees of freedom, is not in the table, always work your way back to the smallest one on there. Okay, so here's kind of the idea. It's very similar to what we did in 8.1. Your error is what you're going to add and subtract your sample mean, and that's just going to change a little bit because now you're using a critical value that's t, and you're using the sample standard deviation. So here in this next slide, I've got a nice little flow chart as to what happens between the two. The process is a lot the same. It's all about asking yourself, do you have the standard deviation that comes from the population? Yes. Then it's the normal distribution. You're using your normal standard deviation. You're using a z-score. If you say no, then you got to find the degrees of freedom. You're going to use your sample mean or sample standard deviation, and you're going to have to use a confidence interval that comes from the t-score. Okay, but in both cases, you're going to work your way down to using the sample mean and adding and subtracting that error. So example 1, the mean weight of 8 fish caught at a local lake is 15.7 ounces. So here we go, 15.7 ounces came from a sample of 8 fish. The standard deviation from those 8 fish is your 2.3 ounces, so there's your sample 1. Your degrees of freedom is going to be 8 minus 1, or 7, and we want to come up with a confidence interval that is going to work out for 90%. So again, I'm looking at the very front binding. I find the 0.9, go down to degrees of freedom of 7, and I get 1.895. Okay, that's the student T one from the very front of your book. So my error is going to be the 1.895 times your standard deviation divided by the square root of n. Now, I like to do the fraction first, just to kind of eliminate some of my possible computation errors. And I get 0.9899, and then I'm going to multiply that by 1.895, and I get an error of of, it looks like about 1.876. So I'll take my sample mean of 15.7 minus that error. And I'm going to take the sample mean of 15.7 and I'm going to add that error. And that's going to give me my confidence interval. So my lower bound of that would be 13.82. And my upper bound of that is going to be, let's see here, 59.1.876, 17.68, I think is what I went around. So I can say that I'm 90% confident that the mean fish weight is between 13.82 and 17.68 ounces. Yeah, so that confidence intervals if you're given the sample standard deviation instead of the population interval. Okay. Following report counts concerning margins of victory. Okay, 190 Major League games played between July 26 and August 8, 2012. The margin of maybe one run happened 38 times, 2 runs 37 times, 27 times, and so on. The sample mean of those runs per game worked out to be 3.93 and a sample standard deviation of 2.66. So if we're going to do a 99% confidence interval, we have to look up, degrees of freedom for n is equal to 190. Now, I'm sorry, not that. It's going to be 1 minus that, 189. If you look in the book, though, 189 isn't in there. So I'm going to go to 100. And for 99%, careful, don't look up 99.9%. I have a t-score of 2.626. Yeah, so to figure out my error, I'm going to take that 2.626, all right, times the sample mean of 3.93 divided by the square root of 189. Oh, sorry, not 3.93. I just used the sample mean instead of the sample standard deviation. That's going to be 2.66. So again, 2.66 divided by the square root of 189. Okay, times the 2.626. So that's going to give us an error of 0.51. So your sample mean of 3.93 minus that error and 3.93 plus that error. So 3.93 minus 0.51 is 3.42. And adding that onto there, I get 4.44. So we're 99% confident that the average margin of victory is between 3.4 runs and 4.4 runs. Here's your assignment that you can work on, page 4, 20, 1 through 5, 7, 11, 15, and 17. We'll probably do a couple in class as well. I would get a lot of practice looking up t-scores and being able to read that table correctly. That's probably the biggest thing, other than deciding on whether or not to use t-score versus z-score.